Hello guys, how are you? This is Daniel Pinheiro from danielpm1982.com, and in this video I'm gonna show you how to install on Linux the best integrated development environment or IDE, which is IntelliJ IDEA Ultimate. IntelliJ is produced and maintained by JetBrains, whose site is this one, jetbrains.com. So first let's go to JetBrains site and take a look at it. So here it is, the JetBrains site. Let me just accept the cookies. Okay, you can take a look at all their site information. As you see, their products are used by the biggest companies we have, and most of Java developers are making this change from Eclipse to JetBrains IntelliJ, and I'll show you, in part at least, in this video, why is that happening. If you see here on Tools, you can see that JetBrains is responsible for many development tools or technologies that you can use. And in the case of this video, and for Java development, the main tool is the IntelliJ IDEA, but JetBrains also has some other IDEs for other languages, as Python, as Ruby, as PHP, as .NET, as for databases, big data management, and so on. But in this video I'm going to show you how to install IntelliJ IDE or IDEA Ultimate. You just go to IntelliJ page, and in this page you can take a look about the overall advantages of IntelliJ and what this IDE offers regarding the intelligence of the algorithms, the experience it offers to the programmer or developer, the code completion or generation. But we'll see in practice each one of the main characteristics of it. Here you can see the built-in tools, supported frameworks. For example, IntelliJ already comes with built-in integration with Git for version control, as well as database management systems as for SQL. IntelliJ supports primarily these four languages for JVM, Java, Scala, Groovy, and Kotlin. It also has native support for Spring, and it's one of the main advantages of this IDE. I'll show you in this video how easy it is to create a Spring application or a web service using IntelliJ. It also has built-in support for Java Enterprise Edition as servlets, expression languages, JSPs, and so on. It also supports Grails. For mobile development, it also supports Android development, Reactive Native, Cordova, and Ionic. And for web development, it also has built-in support for JavaScript and TypeScript, for HTML and CSS, and for Node.js, Angular, and React. So all this you have built in your initial installation of IntelliJ, and also you can add a lot of plugins for many other sorts of integration with other technologies. One thing that I'd like to remind you is that IntelliJ is a Java software. It's all implemented or created using Java language, so for it to run after installation, you gotta have installed already in your system Java 8 or later. And if you don't have yet any Java JDK installed on your Linux, you can go to my site, danielpm1982.com, and there you find a video about how to install OpenJDK versions 1.8 and version 14, which is for now the latest version available both for OpenJDK as for Oracle JDK. And also there you find another video about how to install Git in case you wanna use your terminal console for accessing Git, although it already comes with IntelliJ as well. So here you have the difference between the two main versions of IntelliJ IDEA, which are the IntelliJ IDEA Ultimate, which is the one we're gonna install during this video, and you also have the IntelliJ IDEA Community Edition, which is an open source one. For this community edition, you don't have to buy any license, but in case you wanna develop any Java web system, you either have to upgrade to the Ultimate Edition in order to have inbuilt support for Spring, for Java Enterprise Edition, for Swagger or Open API, for JavaScript or TypeScript, and for database tools for SQL, or you gotta find a plugin in order to be able to use those technologies. So if you, for example, you can download a plugin for Spring, and then you can develop a Spring application. But actually, I have not yet tried that. Since the beginning, I'm using the Ultimate Edition, which already comes with everything supported. But in case you're only able to keep the Community Edition, then you can search for the plugins to develop web applications as well. In both editions, you already have support for Java, Kotlin, Groovy, and Scala, for Android, for Maven, Gradle, for Git, but on the community version, you won't have support for mainly for the Spring Java Enterprise Edition or for JavaScript or inbuilt database tools. So it's up to you to decide which edition to use, and you can also use the free 30-day trial for the Ultimate Edition. And in case you like, you buy the license or you go to the Community Edition and search for those web development plugins. And actually there's a third edition for students and teachers, which is the IDEA Educational, which is part of the IntelliJ IDEA Academy initiative. But in our case, we'll keep with IntelliJ IDEA Ultimate, which is the most complete version available. So if you click here on download, it will go to the downloads page where you can choose which version you want to download. Here you can download the tar file for Linux, or you can also, down here it shows how to install from the terminal if you're using any Debian distro of Linux. You can install from your terminal by using sudo snap install IntelliJ IDEA Ultimate -- classic. But there's an still easier way to install, which is simply going to the store and look for IntelliJ IDEA Ultimate. So here it is. You can just click on it. In our case, we are installing the version 2020.1.2, which is the latest stable version available for now. So for installing, you just click here, install, and type your password. Now it's installing. Okay, now it's finished installing, and we can just launch the application. But let me close here and launch by clicking on the starting icon. You agree with the user agreement. I'll choose to don't send any data for statistics. Here you can choose either the dark view version or the light one. You can also change that later, including for the different plugin views, but in our case we will just select the darkular. Next, here we have the default plugins that come with IntelliJ Ultimate. You can just accept all that and click on next. Feature plugins, also accept all that. Just start using IntelliJ by clicking here. Okay, when you try to open for the first time your IntelliJ IDE, the first thing it's gonna ask you is for an active license, and you have some options here. For example, you can select here evaluate for free for using the 30 days trial period, and then you put your address here and click evaluate. Or you can, especially if that 30 days time period expires, you can buy a license by clicking here. Or in case you have either an still active license registered, which is my case, you just make your login to JetBrains here, and it will detect automatically your eventual existing and valid licenses. Or you can grab here any activation code you have in order to activate it. In my case, I still have an active and valid license registered with JetBrains, so I'll just make my login here and it will detect my active license still available. Okay, so for logging in, you just now click activate and it will find, in my case, my still active license and link that with the application we've just installed. Okay, it's found the license and now it's opening the application. So here you have the option to configure your application or create a new project or open or import an existing project or even clone and check out an existing project from your Git. But we'll show you how to use Git later. So first, before we create any project or import any project from GitHub, let's configure the available RAM memory for IntelliJ to use. And for that, you can click here at Configure, Edit, Custom VM Options. And here we are gonna change basically these 4 initial lines. The first and second ones are gonna be the memory that IntelliJ is going to use and the maximum heap memory available. So we'll just set both of these values to half the available RAM of my system, or in your case of your system. In my case, I have available 16 gigabytes of RAM, so I'll set here 8 gigabytes of RAM for IntelliJ to be able to use. And you can just set here, instead of megabytes, you can set 8G from gigabytes. And here for the XMX, also the same. Instead of 750 megabytes, we're gonna set 8 gigabytes. Another thing we're gonna set here is the reserved code cache size. We're gonna simply double it to 480 megabytes. This is the memory available for the JVM to use as its cache. And the last thing we're gonna change is this garbage collector algorithm type. Instead of the use conch mark sweep garbage collector, we're gonna use the G1. You just change this for G1. So this is the new garbage collector type you're gonna use, which is use G1 GC. So it's basically the same algorithm of the other one, but it cleans more frequently every small portion of unused data instead of waiting too much to clean it up all at once. And as such, it avoids freezing your application at that time. So that's basically it. You just click save and it will save these IDEA 64.vm options. So now that we've set the custom VM options, we can now create a new project. And for that, we'll just create a simple Java SE project, but you can also create a Java Enterprise Edition project, or a Spring Maven one, or a Spring Initializer one. As you can see, all this is inbuilt to IntelliJ. For example, you won't have to go to the Spring Initializer site to create and then import that. It will be created all internally if you select this option here. You could also create a Maven project, which could not be a Spring one. You could also create a Gradle one, a Groovy one, a Grails one, or a Kotlin one, or a JavaScript one, or even an empty project. But let's create firstly a Java SE simple application. And for the project SDK, you here on the right select whatever JDK you have installed. In my case, I have installed both the OpenJDK Java 1.8 as the OpenJDK Java 14, which is actually my default one. So that's why it appears here, and we'll just keep that. Here below you don't have to select anything for now. Just select next. Check here create project from template for just adding a main method to our main class. Next, here is the project name. Let's put as project 1. Here below you have the project location, so we gotta set the folder we've just created, which is the IntelliJ workspace, slash the project name, which is the folder where the project will be created and all its files be put into. And here below we have the base package that I'll just set as con.danielpm1982, but you can set whatever base package you want. So the structure for our project will be the folders, the workspace folder, and inside that a folder project 1, and inside that we have the path or the sequence of folders con Daniel PM1982, and then we'll have the files, in our case our main class, inside Daniel PM1982. Later you can add any number of folders inside this Daniel PM1982, but here you just have to set like this. Then finish. It's just saying that it's gonna create the project 1 folder inside the workspace. Okay. And here is our first IntelliJ Java SE project. You can open up here. So inside the workspace we have the project 1 folder, and inside that we have the con and the Daniel PM1982 packages, and inside Daniel PM1982 we have the main class, which is this one. Okay, and after creating our first project, the first thing that I'm gonna show you how to configure is to increase the editor font here. It's too small for you to see, so for increasing the font of the editor, this is the editor section of the user interface. You go to File, Settings, Editor, and Font. And here you set whatever size you want. Let's set a 20 size font. Okay, now you see that it's more visible for you. And now let's just type here the system.out.println. Let's just say here hello world. Okay, so for running any class you can select with the right button and run, or even debug that class, or here on the editor itself you can just press on this arrow here, either at the method or at the class. If you press here, you're saying that you want to run the class. If you press here, you're saying that you wanna run this main method, which is inside this class, so the effect will be the same. So just press either any of these arrows, run main. Okay, here is the result at the console, which is simply an out string message saying hello world. So as this, we've created and run our first IntelliJ application, and we've also customized the font size for the editor section of the IntelliJ user interface. Here at the project section, you can check the structure. For example, here inside the project one, you have the .idea, which is basically some configuration XML files specifically used by IntelliJ. You don't have to change anything here. So this .idea is in a specific folder for IntelliJ to use for this project. And also when you push the project to GitHub, you will include this .idea folder as an exclusion for your pushings or for your commits, because it's basically only needed for IntelliJ as a configuration folder for the project, but not for the code itself. Here at the out folder, you have the compilation of that code. For example, we've created this main class, which is main.java, using the Java language. And when we set here to run the class, the IDE has called the JavaC or Java compiler to compile this main.java to a compiled file, and it has put that inside this out folder and inside the whole folder structure that we've created. And here you have the main.class, which is unreadable for us, but it is readable by the JVM. So when you create any Java project, each class you create is saved into a .java class. Then it is compiled to a .class file, and then the JVM will use that .class file to send the instructions for the processor to run any algorithm we have at that code. So, taking advantage of this very simple Java SE Hello World example, let's now see how IntelliJ automatically generates Pojo's code, specifically the accessor or getters and setters methods, the constructor, and the hash code and equals methods for your domain being classes, which are basic to any project you may ever create using Java. So let's close here the out directory. The out is the destination for the compiled code. We won't have to worry with that. Let's go to the source directory, which is the folder where all our code, our source code, Java code, should be put into. So we have already the com.danielpm1982 packages, and let's create another package, which is basically a folder, but now called domain. It's generally where we put domain classes or Pojo's classes or bean classes for our applications to use. So before we start implementing our domain classes, let me first present you the data model we're gonna use for this example as well as for all other examples we're gonna create during this course. So let me paste the PNG files to a new directory called images. Paste, refactor to that directory. Okay, these are the two PNG files for the entity relationship model as well as to the relational model. And if you want, for example, rename any file, you can click the right button, then refactor, then rename. And IntelliJ will not only rename the file, but refactor it anywhere it has been used before. So this is the entity relationship model of our data model. Observe that we have only 4 entity types: the client, the other item, and the product. So between client and other, we'll have a one-to-many relationship. So a client will issue many orders, and each order will be issued by at most one client. And this will be a total relationship, because there can't be another instance without the relationship of it being issued by a certain client. So for all other instances, a client related to it must exist, but the inverse is not like that, because a client instance may exist without issuing any order. So from client to order we'll have only a partial relationship, but between order and client we'll have a total one. I also put the minimax representation here, although we didn't need it, because we have also this other notation here that already shows when a relationship is total or optional, and when the mean is 1, or when the max is n. But anyway, this is a one-to-n relationship between client and other, and a n-to-1 between other and client, and then between other and other item. Another will have many other items, which will be like the lines of the order, and the other item will be contained inside at least and at most one order. So this will also be an identifying relationship, and other item will be a weak entity, because for any instance of it to exist, it must unite the partial key with the primary key of the order that will identify that weak entity, in order to the other item instance to uniquely exist. Other than that, as you can see here, the mean for other item as well as the mean for the order are both 1, so both ways of the relationship in this case are total, which means for each order instance you must have another item associated, as well as for each instance of another item you must have another instance associated to the other item. And then we have a last relationship between order item and product. Each order item contained at an order from a certain client will include at most one product for this order item. Of course, inside an order you will have many order items, so inside an order you will also have many products. But for each line of that order, for each order item, you'll only be able to include one product. And for each product, it will be able to be included in many different order items from different orders from different clients. And now let's see the relational final model for this entity relationship model, which is this one. So here you have the 4 tables of our database, which will be client, order, order item, which is our weak entity when transformed to a table, and also the product table as well. So the client table will have a primary key of client ID, and then some attributes as client's name, email, street number, city, country, birth date, and an optional attribute or field called client info in case you wanna add any information for that client that can't be put into these other fields or columns. And then for the order table, we'll have the order ID as the primary key, and as attributes or fields or columns, we'll have the time, the date, the order info, just for any additional string information you wanna add to that order that can't be added on the other fields. And as a foreign key, we're gonna have the client ID, which is the primary key of the client. So the order table will refer to the client table, because in any 1-to-n relationship you gotta put the primary key of the one side entity into the n side entity when you produce the relational model. So the client is the entity which will have many orders, so we gotta put the primary key of client inside the n side or the order side of the relation. So at least at the database we won't be able to know the orders for each client taking as origin the client itself, because the client won't have any attribute or field pointing out to the orders, even because you can't have lists into a table. If we were to create any field here at clients to point out to order, we would have to create a referential table here, as we would do with an end-to-end relationship, and use the primary keys of both as the 2 foreign keys that would compose the primary key of this third table. And for avoiding that, it's much simpler to not use any relationship attribute inside the one side of the one-to-many relationship, and use only the primary key as a foreign key inside the n side table, which is the case we did here, because each order will relate at most to one client. So we only have a simple and not a multi-valued field or attribute. And for the order item, as we've talked before, the primary key will be the combination of 2 keys One is the original key from the other item, which is a partial key. It's not a full primary key, as the other item doesn't exist on its own. It's identified by another necessarily. So the primary key of the other item will be the combination of the other item ID from the other item itself plus the other ID, which is the primary key at the other table. And here at the other item, it's also a foreign key. So this foreign key, other ID, plus the partial key, other item ID, will make up the primary key for this weak entity, other item table. And also we'll have the quantity of the product included at this other item, any discount value for this one and only product of this other item, the price of the product for this other item into that specific order, the other item info, also for any other string information you want to add to the other item, also optional, and for relating the other item with product, for that many to one relationship we had, we'll put the primary key of product inside the any side of the relationship, which is other item, as a foreign key product ID. So this relationship between other item and product, if you remember the entity relationship model, is a many to one and not a one to many. So that's why in this case the product ID, it's gonna be into the other item, because the other item is the entity type or the table at the inside of the relation, and make a relation from the other item to the product. So from another item we can know what product it has, but from each product we won't be able to know which other items include that product, at least directly here at this database model. You see that at our software, or even using SQL at the database management system that we're gonna test later, we'll be able to show a final table, joining relations and representing whatever we want to show, including for each client which orders he has, as well as from each product which other items will have included that product. But here directly what we can is to know which client is related to another, which order is related to another item, and which product is related to the other item. So this is it. This is our data model. And on the next examples, where we're gonna use databases, we're gonna create this schema with these 4 tables, and we'll use this schema with all the example projects we're gonna create starting from this one. But in this one we'll not use the database for now. We'll just implement here some domain classes to represent these 4 tables and their content. So we'll create a class for representing the client. We'll create another class to represent the other. We'll also create another class, other item, to represent the other item, and a 4th class, product, for representing the product table. Remember that in a real system, you would have all the tables at the database, and you would have the classes at your code, and those classes would have to model somehow that database schema. But we'll talk more about object relational model on the next video. So in this example, we'll just create the classes for modeling these 4 future database tables.